to graph this quadratic equation using its properties and make sure we label the vertex, the intercepts, and the axis of symmetry. For this particular one, I first noticed that my a value, which is the coefficient in front of x squared, is 1, which is positive, so this will open upwards. Now I also noticed that I could find my vertex by finding my x-coordinate using negative b over 2a. And it's kind of hard to see what my b is. It's supposed to be the coefficient in front of x, and there isn't a term that's just an x. So that means that the b is 0, and my a is 1. So plugging that in, I get the opposite of 0 over 2 times 1, which is just 0. So now if I plug that in to find my y-coordinate of my vertex, y is going to be 0 squared minus 4. So y is negative 4. So my vertex is at 0, negative 4. Notice that that's also the y-intercept. So the y-intercept is 0, negative 4, and my vertex is 0, negative 4. Now let's find our x-intercepts. Notice that when you are looking for x-intercepts, that the y value on the horizontal axis is 0. So we're going to let y equal 0 in this and solve. That makes 0 equal to x squared minus 4. I can use the square root property to solve this. If I add 4 to both sides, I get 4 equals x squared. And then if I square root both sides, making sure I have a plus or minus over here, I find x is plus or minus 2, which means x equals 2 or negative 2, which means we're going to have 2 points for our x-intercepts. We will have 2, 0. The other point will be negative 2, 0. Let's plot those. We have negative 2, 0, and we also have 2, 0. So we have the x-intercepts, the y-intercept. My axis of symmetry is actually my y-axis, and that's got an equation of x equals 0. If I connect the points that I have here, notice that I get a nice parabola that goes through x-intercepts at negative 2, 0 and 2, 0, has a y-intercept at 0, negative 4, and an axis of symmetry that is the y-axis, which is x equals 0.